Our inconceivable lead is way out of this world, 390 light-years away, truth be told. For setting, 1 light-year is indistinguishable from 6 trillion miles. In humanity's determined mission to shed light on the mysteries of the universe, we have begun a trip that goes beyond time itself, searching for responses to long-standing questions woven into the fabric of existence. The James Webb Space Telescope's unwavering gaze has recently recognized a brief glimpse of a structure predating the presentation of stars. This magnificent thing appeared to be more ancient than the universe itself, raising more questions than it answers. How might a structure exist that predates our universe? Or is the hypothesis of how things came to be at fault? Join us as we set out on an odyssey guided by the discoveries of the James Webb Telescope, where the secrets of a 13.8 billion-year-old cosmos await. Furthermore, the journey to unravel these colossal mysteries has just barely begun. In a distant corner of the universe, around 200 light-years away, an old star called HD 140283 resides near the Libra constellation. This magnificent voyager moves energetically through space, revealing fleeting glimpses into its violent past. Precisely a few billion years ago, when our Milky Way was still in its infancy, it absorbed a dwarf galaxy that once called it home. But what truly satisfies our cosmic fascination with HD 140283 isn't just its fast cycle, it's its remarkable age. Among the stellar entities we've observed, it remains one of the oldest, earning the charming moniker Methuselah star, a nod to the biblical figure Methuselah, who, legend has it, lived for 969 years. Initially estimated to be a dazzling 16 billion years old, the latest estimates suggest a somewhat younger period of 14.46 billion years, with a margin of error of 0.8 billion years. This revelation spans roughly 1 billion years and has confounded astronomers. After all, the universe's age, as determined by the microwave cosmic background, lingers around 13.8 billion years. This issue raised major questions about the star's age, the universe's age, and even the accuracy of our dating methods. Let's break it down. Figuring out the age of stars can be a real challenge. Take stars like the Sun. They're akin to timeless lights, maintaining their radiance, temperature, and size for billions of years, making them intriguing to age date. Space scientists use changes in brilliance and color as clues, combining these with models predicting how stars evolve over time. One age giveaway is how quickly a star spins. Like a wheel slowing down over time, stars do this too. By comparing the rotational speeds of stars at different ages, astronomers have discovered a clever technique known as gyrochronology. Stars also spill their age secrets via enticing conversations. A star's flares and energy emissions surface, resembling fiery bursts. Astronomers, the investigators of space, employ advanced techniques like astroseismology. It's like eavesdropping on a star's internal conversations, focusing on vibrations caused by waves traveling through its layers. These vibrations reveal the star's internal age. For instance, using this cosmic snooping, space scientists aged the Sun at 4.58 billion years. Now back to the Methuselah star. The old radiation around it isn't just inconsistent. Space scientists tagged it with an ancient age by checking its cosmic metal content. Stars can be classified into groups based on how much bling, or heavy elements like iron, they have. Our Sun is somewhat of a metalhead, belonging to population 1 stars. Methuselah star, on the other hand, looks like an old relic from population 2, rocking fewer heavy elements. It's a helpful cosmic fingerprint. Astronomers act as archaeologists of the galaxy, unraveling the age stories of these celestial bodies. Now imagine a gathering of stars, population 3, which analysts believe might be the universe's most extraordinary treasures. While they last, they hide in the background and haven't yet appeared in our telescope's spotlight. Stargazers suspect these stars might be the legends of creation, containing almost no heavy elements. To understand the grand plan, we need to rewind to the universe's early days after the Big Bang. Picture an endless kitchen filled mostly with hydrogen and helium, the universe's essential ingredients, about 92% hydrogen and 8% helium, or approximately 75% hydrogen and 25% helium, depending on the model. The first performers in this massive ensemble were the population 3 stars. They were enormous and hot, burning their fuel rapidly, changing hydrogen and helium into heavier elements. When these early cosmic giants exploded, They spread these heavy elements into the vast cosmic expanse. Next came the population 2 stars, forming a bit later in the universe's early days. Their original materials were already infused with heavy elements, particularly iron. They lived through their celestial life cycles, exploded into supernovae, and added even more heavy elements to the universal mix. Eventually, the population 1 stars, including our Sun, emerged as cosmic mavericks, forming from advanced gas clouds blending with the remains of the earlier population 2 stars. Now, the central question: does the grand story throw a cosmic curveball at the theory of the ancient cosmic explosion? It's a head-scratcher. But here's the twist. There's a 70% chance that Methuselah's star, the old cosmic vagabond, could be in the vicinity. A 13.66% chance that this ancient celestial wanderer's age is playing similarly outside the cosmic rulebook. And a 15% chance it's not quite as old, but much younger. Imagine rolling a standard 6-sided die and expecting one of 6 statistically possible outcomes, regardless of what these may reveal. Regardless of what these probabilities tell us, the mere existence of such an old star challenges our most foundational beliefs. If HD 140283 truly is older than the universe, or even close in age, then we may be missing something critical in our understanding of cosmic evolution. Could it be that our calculations are slightly off? Maybe our measurements of the cosmic microwave background need refining. Or perhaps, more provocatively, this star is evidence of a previous cosmic cycle. A universe that existed before our own, reborn in the fire of a new Big Bang. These are not just idle speculations. Theories like cyclic cosmology or multiverse models gain fuel from anomalies like the Methuselah star. If matter from a prior universe left any trace behind, an ancient star with inexplicable age would be the perfect relic. As scientists refine their tools and telescopes, from the James Webb to the future Roman Space Telescope, we edge closer to uncovering deeper truths. We're now able to observe galaxies that formed just a few 100 million years after the Big Bang, and we're beginning to peer into the foggy veil of cosmic dawn. Every observation challenges us. Every unexpected reading forces us to look again, revise, and sometimes rewrite the textbooks. The Methuselah star may not be an error. It may be a messenger, whispering stories from a time before time. So what lies ahead? Possibly the discovery of true population 3 stars, untouched by the heavier elements of previous generations. Possibly more ancient stars that defy logic and hint at pre-Big Bang physics. Possibly the unearthing of evidence that we are not the first iteration of the cosmos. For now, we continue our search, eyes on the skies, data in hand, and wonder in our hearts. Because in this vast universe, every answer opens the door to 1,000 more questions. And with each step forward, we remember, we are not merely observers of the cosmos, we are part of its story. Curves of the cosmos throw at us what's certain. Methuselah's star is more than just a gigantic veteran. It's the granddaddy of stars. We've managed to give it an age label that's incredibly precise. Now, here's where it gets interesting. Instead of scratching our heads about how Methuselah's star could be 2 or 3 billion years older than its cosmic neighbors, let's change the cosmic script. What if the universe itself isn't as young as we once thought? Consider trying to comprehend how vast space is. If we turn the entire history of the universe into a cosmic calendar, with the most monumental new creation, the Big Bang, as New Year's fireworks, Earth wouldn't join the cosmic party until the final seconds of December 31st. Human written history? That's only a blip in time, covering just the last 10 seconds. Our cosmic agents determined the universe's age by looking at old starlight, born a few 100 million years after the Big Bang. As the universe expands, it gives this light a vast makeover known as redshift. By doing the math on both distance and expansion, scientists declared a general age of 13.8 billion years. But hold on, because the cosmic situation starts to get enthralling. An endless stream of ideas from the University of Ottawa suggests the universe might be a whopping 26.7 billion years old. Professor Rajendra Gupta introduces a fascinating theory from 1929, created by Fritz Zwicky, a Swiss astronomer, and it's stirring up our cosmic thinking. This theory complicates matters, proposing that as light particles, photons, traverse the infinity of space over time, they lose some of their energy. Though this idea doesn't perfectly align with what we've seen through our telescopes, Gupta proposes a cosmic trade-off. He suggests we can blend this theory with our current understanding of an expanding universe, creating a hybrid explanation for the redshift phenomenon. Now fasten your seatbelts. Changing the universe's age to an astounding 26.7 billion years is no small feat. Gupta adds another twist to the cosmic mix by combining the photon light theory with evolving coupling constants, a brainchild of theoretical physicist Paul Dirac. This idea proposes that how particles interact may have changed over time. And hey, scientists have a history of tweaking the cosmic clock. In the 1920s, Edwin Hubble believed the universe was just a simple 2 billion years old. Since then, we've come a long way in improving cosmic math. Multiplying the universe's age is like taking a giant leap in our cosmic vision. But we should pause for a moment. Whether this new perspective becomes the galactic norm is still up in the stars. Regardless of whether humanity's written history is a mere blip of 10 or 5 seconds in the grand scheme of the universe, one thing is clear. The universe is a treasure trove of ancient wonders and endless inspiration. Looking to our astronomical backyard, the Milky Way, there's a stunning cosmic tango at play. Recent estimates hint that stars on the edges of our galaxy are strutting their stuff in slow motion compared to their partners in other galaxies. Cosmic scoop? There are a few. One theory is that our Milky Way might be running nearly out of an invisible cosmic ingredient called dark matter. This mysterious substance affects the gravitational dance of magnificent objects. There's an infinite riddle involving dark matter, the elusive substance we can't see, but that seems to play a gravitational back and forth in the universe. One possibility shaking our grand understanding is that perhaps we've been measuring dark matter wrong. Our universal compass might be pointing off course. Here's where the European Space Agency's satellite, Gaia, enters the cosmic spotlight. It's like our cosmic expert, offering intricate insights into the dance of nearly 2 billion stars in our Milky Way. Think of it as a massive development test. The satellite's exact measurements have led astronomers to reconsider their grand cosmic notes. Stars at the outer edges of our Milky Way seem to be moving slowly, testing our old assumptions about their speeds. How do star speeds spill the cosmic beans about a universe's mess? It's like gauging the size of a gathering by how fast people are moving. Armed with Gaia's data, space scientists estimated the combined mass of our galaxy's gas, dust, stars, and that elusive dark matter to be around 200 billion times the mass of our sun. It sounds like a galactic heavyweight, but here's the twist. It's several times less than we previously conceived. A single theory to settle this grand issue suggests we may have made excessive use of our dark matter estimates. Perhaps there's less dark matter than we imagined. However, hold tight. Measuring the universe is like trying to achieve the impossible. The data could have some quirks, or our cosmic measuring tape might need some alterations. Additional research groups have joined the cosmic investigation, and they appear to be all speaking the same universal tune. If this grand discovery holds, it's like opening a new chapter in our physics textbook. A shift that might make us rethink not just our Milky Way, but every glittering nook and cranny of the universe. As Stacy McGaugh, a space expert at Case Western Reserve University, puts it, this could be a cosmic game changer. Returning to the cosmic journey of the 1970s, when astronomer Vera Rubin and her immense team embarked on a celestial mission. Their goal was to study how stars moved in different galaxies. The big playbook suggested that stars on the edges of a galaxy should be slow compared to the zippy stars closer to the center. It's like how Neptune moves slowly around the sun, while Mercury is the speedster of the solar system. Here's where the unexpected developments occurred. Rubin and her stargazing team uncovered a galactic surprise. Stars at the far edges of galaxies were strutting their stuff at almost the same speed as the ones closer to the cosmic dance floor. Imagine a vast disco where everybody, regardless of where they are, is moving to the same beat. This cosmic revelation suggested the existence of something complex and secret, dark matter, the invisible heavyweight champion that forms huge halos around galaxies. Think about the early space scientists, like Copernicus and Kepler. We've learned a lot since then, but we're still the learners, wide-eyed at galactic wonders, trying to solve the universe's mysteries. Our Earth is like a tiny island in the vast expanse of space, orbiting the sun, surrounded by endless stars in our little galaxy. Our quest for significance among the stars is the heart of scientific investigation. Even when answers surprise us, this curiosity keeps us traveling further into the universe. It's an endless journey, where every answer brings new questions, ensuring our grand exploration never stops. The universe continues to astonish us with its vastness and complexity. Each discovery leads us deeper into the intricate tapestry of galactic history, revealing the fundamental rules that govern our reality. As we push the boundaries of understanding, our telescopes evolve, becoming more than just instruments. They're portals into the past. Every photon they catch is a messenger from an ancient time, a flicker from billions of years ago whispering secrets of creation, destruction, and rebirth. Projects like the James Webb Space Telescope are now stretching our vision even farther. Peering into the deep infrared, it's like unearthing the baby pictures of galaxies, some so young they're barely formed, yet already shaping the cosmos around them. We're watching galaxies collide, stars being born in glowing nurseries and black holes devouring light itself. These revelations aren't just science, they're poetry in motion. Even as we decode the cosmic symphony, questions multiply. Why does dark energy seem to be speeding up the universe's expansion? What exactly happens at the edge of a black hole's event horizon? Could there be other universes, bubbles beyond our own bubble, each with its own laws of physics? And perhaps the biggest question of all, are we alone? The search for extraterrestrial life is no longer science fiction. It's a full-fledged scientific mission. We've found exoplanets in the habitable zones of distant stars, some with potential oceans, atmospheres, even signs of chemical imbalance that could hint at life. Missions to icy moons like Europa and Enceladus may one day crack their frozen shells and search for alien microbes swimming in underground seas. In this grand cosmic arena, humanity stands as both observer and participant. We're no longer confined to Earth. Mars missions, lunar bases, asteroid mining. These aren't dreams for a distant future, but plans in progress. Our species is writing its next chapter, where we may one day become interplanetary travelers. Yet, the deeper we go, the more we realize how interconnected everything is. The iron in our blood was forged in the hearts of dying stars. The water we drink has cycled through countless generations of life. The atoms that make us were born in explosions powerful enough to light up galaxies. We are quite literally made of star stuff. So we gaze up, not just to explore the stars, but to understand ourselves. Each question we answer reveals a deeper layer of mystery. And maybe that's the point. Not to reach an end, but to keep searching. To remain curious. To continue this dance with the cosmos, a waltz through space and time that never truly ends. Because in the grandest sense, the universe isn't just out there. It's within us. And the journey has only just begun.